So this was the overview over all programmable function, and now we jump into the additional diagnostic functions. So the programmable functions were more for controlling the process, and the diagnostic functions are more for the monitoring of the process, not for controlling. So it goes direction preventive maintenance. But we have to say that there is no clear separation. We have a fluent transition between the diagnostic functions and programmable functions. The first diagnostic function is the temperature. You have an output of the current, the minimum or the maximum temperature. And you can also set up temperature limit values when falling below or exceeding a limit of the set temperature. The encoder puts out a certain signal. With this function, you can reduce additional temperature sensors, but you have to say that the encoder internal temperature is measured with this function. So depending on the speed and the installation situation of the encoder, the temperature difference between the environmental temperature of the encoder and the encoder inner temperature can be up to 15 degrees Celsius. So you have to consider this in the application and to do the calculation with this delta value. Example application here is use of an encoder at the axis of a bakery machine, and the encoder is covered with an additional housing and cooled with a pressured air, and the monitoring of the encoder temperature is realized directly with the temperature value out of the encoder, and you don't have to put an additional temperature sensor to this application. So you can save some money for the temperature sensor and also programming effort and connecting effort. Another diagnostic function is the power up counter and the operating and motion timer. So the power up counter counts the number of power on operations. The operating timer counts the time while the encoder is powered, and the motion timer counts the time while the encoder shaft is moving. And either after a certain number of operating hours on power, this has the monitoring of components which have a limited lifetime according to electrics can be realized with that, or after a certain time of motion, and herewith you can monitor the components which have a limited lifetime according to mechanics. You can use these timers or these counters, and you can realize maintenance intervals using these timers or counters. The benefit for the customer is you can save additional operating hour counters, and you don't have to program or to add another additional hour counter or motion timer. Another diagnostic function is the counter for direction changes or the number of movements in a certain direction. So the counter of direction changes counts the number of turning direction changes of the encoder shaft, and the other counter counts the number of turns in clockwise or counterclockwise direction. Again, the benefit, saving of effort or costs for the programming of an additional cycle counter, and the example application in this case is again the lifter that already Achim showed you before, where you can also monitor the lifetime of the wire draw mechanism in this case. For example, the lifetime of the wire draw mechanism is 1 million cycles, and this corresponds to 1 million direction changes, and so you can do a preventive exchange of the wire draw mechanism. Last but not least, the acceleration. The encoder can output the current acceleration, and you can also adjust the units for the monitoring of the acceleration. So there are 3 different units available, e.g. steps per square second. And in addition, there's the possibility again to set limit values. So the benefit for the customer is no need for external acceleration sensors, and you can save costs for the PLC programming of an acceleration analysis, which causes lots of effort. Example application in this is the protection of the application in general against exceeding acceleration.